Have you ever opened a code file, like an old one sitting on your hard drive in a project, or pulled an old repo from GitHub and sat there and kind of looked at your old code and thought, what the hell was I doing? At some point, most developers will hit a wall, not necessarily because they're bad at coding or because they don't have a good understanding of the domain that they're working in, but because they struggle to make a certain type of transition from high volume coding, where you're kind of just hammering things out at a rapid pace and just getting things in place and getting things working, to a more long-term scalable code design that will serve for months or years into the future. We're going to be talking over some of the concepts around structure and code organization that don't always end up in the spotlight. You might hear bits and pieces of them from articles that you've read online where somebody may allude to something, or you may have learned some things from LLMs or from YouTube videos or training courses that you've done online. But these things sort of quietly determine how your project transitions from being something that's sort of a concept or something really rough and dirty into something that's actually more fun to work on the longer term and doesn't keep you up at night, in a pile of sweat, worried about how you're going to overcome some design problem or anything like that. By no means are the things that we're going to cover the only answers that are out there. There are a multitude of different ways that you can tackle a code base once it gets to that point where you're feeling like there's a lot of friction. But we'll also try and talk over the how of why you would do things certain ways, or the reasoning for certain types of groupings and things like that in your code base. The goal here is simple. I want to walk through types of engineering, things around behaviors, practices, and tips that will kind of help you keep your projects on the rails, whether you're starting a new one or trying to kind of rein in an existing code base where you've gotten to the point where things feel a little bit out of control. Now, the good news is this applies across all types of engineering, whether you're writing native applications, building for the web, or you're just starting a new sort of embedded system or a mobile app, games, whatever the field that you're working in. The principles that we'll cover over here are more or less universal. Sure, tools like LLMs can help with some of this, but you need to understand as an engineer how to avoid backing yourself into a corner when you're developing a code base further. What you really want to avoid is sort of hitting the wall when you suddenly realize you need a massive refactor or to unpick large parts of your code base in order to be able to move it forward. And I've done it loads of times. I know lots of other people who have done it loads of times, where you just get really excited about cranking out code at the beginning of a project and you don't put enough thought into how you are going to structure and organize that on the longer term, and you end up in this position where everything just feels like such a mess that it would be easier to just toss it all out the window rather than try to address the problems that you've introduced through sort of really rapid iterations. Now, there are tons and tons and tons of formal principles out there that you can ascribe to, things like solid, grasp, dry. The list is never ending, the number of things that you can kind of pick up and adopt or piecemeal use. I'm not going to be going through some sort of preconceived set out formula for you to follow in order to ensure some high level of success. I'm only going to cover over specific topics that I know for me and in general across the industry have net benefits for you if you try to adopt them at the right time. If you're lucky, you might have some access to some senior software engineers or lead software engineers, people with a lot more experience and sort of years under their belt. That's one of the best ways to learn, is to ask questions. Ask any kind of questions. There are no stupid questions when it comes to software engineering, because there's such a vast breadth of knowledge and information out there, and some of it can be very subjective. What works for one person might not work for the other one. But one of the ways to kind of cut through all of that, especially in an organization that has a fairly sizable software engineering team, is to seek out seniors but with more experience and ask them questions and get guidance and mentorship. Another way that you can learn a lot is by looking at more mature, well-structured code bases in sites like GitLab, GitHub, and SourceHut. But keep in mind that when you're looking at code on GitHub on something that's a fairly mature project, it didn't start out the way that it looks on GitHub. It may look very well structured and have lots of clear and concise sort of guidance on where things live, but it probably started out really, really, really messy, and you've missed out on that entire period where that code base grew and matured from something that was probably a lot more chaotic into the structure that it has now. now. And that's the reality. Most projects start messy. That's normal. The key is to develop habits that can turn those early messes into well-reasoned, maintainable code bases over time. And the major takeaway here is you want to do this without adding any sort of unnecessary friction, without slowing down progress. You want structure, but you also want to keep moving forward. Here's something that's really easy to forget when you're deep in a project. Your brain can only actually hold so much at any given time. And as your code base grows, the amount of cognitive load it demands from you starts to increase pretty quickly in a lot of instances if you're dealing with something fairly complicated. Early on, your project is small. You can hold most of the moving parts in your brain and reason about them without a ton of effort. As your project grows, though, if you don't sort of impose some kind of structure or create ways to regularly refresh your mental model of what's happening in your application or your service or your system, you'll start to struggle. You'll start to notice it, for instance, when you are doing a lot of jumping around constantly between different areas of your code base, trying to remember how something specific works, or worse, when you accidentally start re-implementing similar pieces of logic in different places across your code base, things that do almost exactly the same thing, and they start to pop up everywhere across your code. Code organization isn't really about making your code look pretty. The intent here isn't to pursue the most beautiful sort of elegant piece of code on the planet. It's to make the code more manageable and to create ways for your brain to easily deal with the complexity, or more easily deal with the complexity at least, of what's going on in that code base. A good structure helps you manage changes more easily, focus on specific pieces without having to reason about the whole system as a whole all the time. It supports collaboration so that multiple people can be working concurrently on the same code base, making changes to key areas without stepping on each other's toes. And it limits repetitiveness, because writing the same code over and over is not only tedious, it's also a maintenance nightmare when you have to update those things further down the road and they touch all these different areas of your code base. And let's be honest, nobody really likes maintaining spaghetti code. You don't have to be like a design patterns guru or, somebody who's been bashing out on a keyboard for 30, 40 years, multiple decades, to be able to build sensibly structured code. And there are some downstream benefits to having well-organized, well-structured code. Things like being able to add tests more easily later on, rather than having to code around tests at the very beginning. So the sooner you think about structure, and you don't necessarily have to impose structure right out the gate, but the sooner that you start thinking about it, the easier your life will be, both in the initial stages when you're just trying to crank stuff out, and as your project scales up in complexity and size. Now, this might sound surprising considering the entire point of this video is about structure, but my initial advice for anybody starting from a fresh project is to start dirty and start flat. When you kick off a new project, you might have a rough sense or scope of the concepts or domains that you'll need to manage. But in the beginning, it's more important to build momentum than to get everything sort of perfectly organized. You can think of it sort of like painting a painting. You don't start out obsessing over the tiny little details in the drawing or in the painting itself. You start with a really loose sketch, and then you progressively build up detail, adding highlights and structure as the piece takes shape. And early on, you probably have some really novel ideas or assumptions you're itching to test out. So don't weigh yourself down by overstructuring too early. You want as little friction as possible between your brain and the code base, especially in those first few sessions where you're exploring the space and kind of figuring out what works and what doesn't. Maybe you're thinking about using events or actors or something more complicated like CQRS patterns. That's fine. Just resist the urge to throw heavy guardrails in place right from the very start that are going to constrain your ability to iterate and test and try things out, because you want that tight feedback loop of trying things, testing assumptions, and pivoting, which is crucial really early on in a fresh project. For most languages, folders and packages and and modules aren't something that's required just to get started. If you start with a simple main function somewhere and sort of write and expand outward into other flat files as it starts to make sense, it'll do you a lot better service than trying to shoehorn things into components and modules and packages too early on. It's a simple rule, but it helps you avoid premature complexity while giving you sort of the flexibility to evolve structure organically as the project takes more shape. Let's talk about patterns for a minute. Design patterns are great, and there are tons of excellent resources out there to help you understand when and where to use them effectively. But here's the thing. During initial development, it's usually kind of too early for anything beyond the most sort of basic pattern. Trying to pick the perfect pattern right out of the gate is a little bit like gambling. There's a non-zero chance that the pattern that you choose early on will actually end up being cumbersome or just the wrong fit as your code evolves. If you lock yourself into a rigid pattern too soon, it can kind of really slow you down later. And honestly, in the beginning, you're probably going to end up using some patterns without even realizing that you are. And you might even accidentally fall into using a few anti-patterns at first. That's okay. Don't overthink it. Don't let the fear of choosing the wrong pattern sort of give you decision paralysis. Your first priority is to just get code down. Once you have a working base and can start to see the bigger picture through the code that you've written up to that point, the right patterns will start to sort of naturally emerge as you kind of grow things. It's a lot easier to refine structure and sort of safer to refine structure once you understand how the pieces of your system interact. So what you want initially is obviously maximum progress with minimum friction. Just get it working. The polish and sort of beautification of your code, that can all come later down the road. You don't need it right now. All right, so a natural question is, when do you actually switch gears? When's the right moment to start adding more structure? And honestly, out of everything that we're talking about, this is probably one of the trickiest aspects. It takes some introspection and self-awareness, and the truth is you'll get better at recognizing this moment the more experience that you build over time. There are some rough signals to watch out for, sort of little indicators that can tell you it's time to shift your focus away from just bashing code out to putting a little bit more structure and thought in. Firstly, something that we've already talked about is you find yourself jumping around a lot in your code base. You're struggling to keep things in your mental model or remember how a specific signature is structured for a function somewhere else in your application, or the specific properties of a struct or a class or instance or something like that that's peppered somewhere in your code base. That's a pretty strong signal that things are starting to need a little bit more structure if you're jumping around a lot. Secondly is you're copy pasting a lot. If you have some chunk of code that you are starting to drop into key places all throughout your code base with minor little changes in it, but it's more or less the same code, it's probably time to think about refactoring to make that functionality a little bit more centralized somewhere so that it's reusable throughout your code base. Another sign, and this is the third, is you're starting to see a lot more merge conflicts. If you're using something like Git and you suddenly see these conflicts popping up more and more and more, it usually means that there isn't enough isolation between the parts of your code for you to do clean changes anymore. Fourth is side effects. The idea here is that more and more often you're starting to see that when you make a minor change over here, there's about 2, 3, 4, 5, 6 other places where that change over here has some massive side effect on other parts of your code, and you have to make changes to all these other areas in order to incorporate that change over on the other side. This is more or less a side effect issue. Fifth is pure abstract terror. If you've gotten to a place where you're sort of building this dread around having to restructure or reorganize your code base, it's usually a sign that you are either starting to get to the point where you need to actually knuckle down and do these things, or you're well past that point already and you're kind of ignoring that part of your brain, your lizard brain, that's telling you danger, danger, danger. We need to readjust and make changes. And sixth and final one, there are probably many, many other signs that you can stick to, but these are kind of the big ones for me at least, is you start to feel like development is slowing down. So you're going to incorporate new features or incorporate new logic and code and things like that, and it feels prohibitively hard to get those things into the code base in a working way cleanly. If you're seeing a lot of friction in terms of adding new features and functionality, it's usually a good sign that it's time to step back and start to rethink how you've structured these things so that they fit together better, or that you can slot things in much more easily. Over time, you'll develop a better sense of when this kind of point happens in your projects and in your code bases. But the key sort of major takeaway is don't let it go for too long. Don't ignore it and don't let it slip and slip and slip, because the longer that you let it slip, the more work, the mountain of work that you have ahead of you just grows and grows and grows and grows. It can start to feel insurmountable, and you might find yourself having to start over completely or copying chunks of code out of your code base into another structure, which can get really tedious. Don't let it get to that point, and don't waste your own time. Make sure that the things that you're building, make sure that you're giving it the respect that it deserves for the amount of effort that you're putting into it by identifying the point when you need to do these things. Now let's switch gears a little bit, talk about some common pitfalls can really trip you up and sort of break things for you early on as your project's growing. These are super common mistakes. If you can avoid them early, you'll save yourself a lot of grief further down the road. First is sort of the infamous common folder, or sometimes people call it the shared folder. These folders almost always turn into a dumping ground. They end up being a catch-all for all the things that don't sort of seem to fit anywhere else in your code and in your project, but they kind of hide a weird trap. Because the name is so general, it kind of gives everyone in the project the license and permission to just sort of toss stuff in there when and as they please, or the moment that they have any kind of minimal discomfort about structuring it properly into the right place. This is a fairly kind of personal one. I tend to avoid having a common folder or a shared folder like it's the plague, just because it's an easy escape hatch when you start to feel a little bit of discomfort or feeling like you don't have time to really think about how to structure something properly. You kind of just dump it into the common folder and walk away. Here's another one that can bite you pretty hard further down the road, even though it might make sense or feel like it makes sense in the very beginning. God objects. These are when you end up having sort of one huge massive class or object that tries to do everything, touching multiple different concerns across your entire project. They feel right at the beginning because you're sort of organizing things centrally, and it feels like you know where everything is. Other than being a very clear violation of the single responsibility principle, it makes your code really hard to reason about further down the line in what pieces of your project are responsible for maintaining what state or content inside of your application or your system. So even though they feel reasonable at the outset, you should try to avoid using a God object or these omni objects at the very beginning, and sort of isolate things by context and domain pretty early on. At first, it might feel like, oh, everything lives in one place, super easy, this is great. But longer term, it becomes a bottleneck and a nightmare to maintain. The only advice I can really give is to avoid using them in general. Be intentional, make an effort to find sort of specific concrete places for scoped bits of what would have been in that omni object and place them in critical places throughout your application. Another one is utils and helper classes or helper functions and libraries and stuff like that. This is similar to the common folder idea, and it suffers from the same problems as the common folder. These can kind of like spread like rabbits throughout your entire code base, where you may have a module or a package that's based around a specific function or a specific concept, and then you've got all of these sort of dumping ground utils files that are in that package around different things. If you need utility files, be specific. Name them clearly, like string utils or date utils, or even more like specific qualified names that signal the responsibility of the things that are in that file. The more explicit that you are, the easier it'll be for everyone to know where things belong and what doesn't belong in those files. Another major sort of hiccup when you are starting to think about structure and code organization, or even when you're first starting out in a code base, is a lack of comments or missing comment. People always debate what the appropriate amount of commenting is, what the right amount of commenting is, where you should comment, the level of detail that you should go into comments. My specific approach is don't comment individual variables. Instead, for instance, give your variables and functions better naming based on the responsibility of that code or the content of that variable, but do write file level documentation at the top of each file that describes what that file does and what its responsibilities are. Another thing that I like to do is actually put like section headings within my files to break the code into sort of discrete, clear areas inside of a given file, and to kind of give it a sort of a narrative flow from top to bottom and organize things so that you're thinking about them from the perspective of somebody coming in and having to read that file rather than them being organized around, well, this was just the first thing that I wrote. The point is that when you revisit that code later or call functions from different parts of the code base, good comments and doc strings give you helpful overlays and type hints in most modern IDEs. So you're not just commenting for other people to come and be able to read and understand your code better. You're also commenting for yourself and for your tools to be able to subvert that need to jump back and forth between different areas of your code base and open up files and hunt to understand how things work that you wrote, 3 months or 6 months ago. Finally, one of the major pitfalls that a lot of people kind of fall into, especially when they start to impose structure and organization, is excessive nesting. I generally stick to a maximum of 2 levels deep for any kind of project structuring in terms of how far down modules and packages will go. If I get down to a 3rd level, I start to really question whether I need that 3rd level and whether that code could live somewhere else more easily. Any deeper than 2 levels, at least for me, starts to feel pretty cumbersome to navigate, especially if you've got a file tree view in your IDE or whatever tool you're using for editing. Having to click down through all those different levels is actually slows you down a little bit. If you notice folders with just 1 or 2 files in them, consider flattening them out. If you've got a module and the only thing in that module is just a single file with a few functions and things like that, bring it up a level and give it a better name rather than allowing it to live as another deeply nested folder in your structure. You can often move files up a level and give them better names to keep the structure simple and much easier to traverse and sort of navigate further down the road. So those are some common sort of pitfalls around structuring that you should try to avoid as you're transitioning into the code organization and structure phase. Next up, I want to talk through some common approaches to grouping your code. We're going to look at this at a high level, things like how you might structure modules and packages, folders in different parts of your project. And just to be clear, this isn't meant to be sort of an exhaustive list of ways to do things or really prescriptive way of doing things. The goal here is simply to get you thinking about the logical units that are inside of your project and what kind of structure might work best for what you're building. Every project's different, so the key is more around understanding the principles and adapting them to your specific needs. Prescribing to one specific type of grouping might get you so far, but what you might find that you could use is a combination of different types of groupings and structurings for the specific type of application or service or system that you're building. With that in mind, let's take a look at some of the different ways that you can kind of group code and group structures in order to impart some sensible organization on things. So we're going to start with the idea of grouping things by responsibility. So that's the overall concept is taking related functions, classes, files, putting them all together based on what they do. So for instance, data access, core business logic, UI components, communications. This kind of overarching organization makes the code easier to navigate because you can tell exactly where some piece of code should live or lives based on what your expectation is of that thing. And when you're organizing things, it's much easier to understand exactly where that thing should slot into, or if it doesn't have a place to live. When you need, for instance, to get some data from a database, you may have a queries folder that interacts with your database where all of your read-only queries live. That makes it easier for people working in your code base as it's more apparent where things live. There's a wide variety of ways that you can group things. So there's sort of feature-based grouping where you lump all code around a specific feature together. There's layer-based where you group code by the overarching layer of your system they represent, like controllers, models, services, networking, GUI components. You can break them down further inside of those packages, but in general, you need to think about what are the high-level code responsibilities that you can bucket your functionality and code into. Another way to organize your code is by the runtime flow. Your project, depending on the type of project it is, probably has some sort of logical stages that it works through that you could organize your code around. At its simplest, it could be there is sort of like an initialization, a processing, and a cleanup responsibility areas. So you could have an initialization folder which deals with spinning up and parsing config, starting up some state, and then a processing module which deals with the actual things that your code executes, and then a cleanup module that deals with all of the leftover bits that need to be destroyed, removed, or released from memory, for instance, as your code base shuts down. A good example is if you're building a web application, you could design around the request sort of layout as it works through your application. So for instance, looking at a startup package that loads up a config file again, and then maybe having a middleware package which deals with authentication and authorization against specific routes, then a route package, a views package, a controllers package, a models package, and service packages to represent the third-party services that your app interacts with. It makes the way that the application actually executes from start to finish a lot more clear for the people that are working within the code base with you. And this makes sense if you're ending up with things like initialization code and runtime code mixed in with each other currently before you've started to build any kind of structure. Another way to group code in general in your repository is by stability. This is something that you could probably mix with the previous two types of grouping. The idea in general is that you have some sort of high-level packages or modules that represent the stability or stage of development of some new features. You could, for example, have a core folder or package and a features top-level package, and sort of stable, mature code goes into the core package. New features and actively being developed areas of the code base can live in the features package. And the idea is that over time, as sort of your knowledge and effort accretes in the features folder, you gradually shift that over into the core folder where it becomes more stable, structured code. You can use any number of structures to sort of denote the state that the code is in, but what this does is allows you to still have that low friction, tight loop between your brain and the code base that you get in the early stages of your project, but later in the project. Inside of these folders, you can expand out to have similar grouping by runtime or by responsibility or some of the other groupings that I'll mention to have the kind of the best of both worlds across the two different types. It doesn't have to be folder based. For example, if you're writing Rust, you can build functionality in a second library or library crate that you can import, migrating it into the core or the main crate as it stabilizes. The idea is generally to group your code by sort of the rate of change. So things that have a lot of high churn go into a specific package. Once the churn starts to slow down, you can sort of move them over into packages that have less churn happening. That brings me into another type of grouping, which is very similar to the stability concept, but is more around the change frequency of code. So grouping your modules based on how often they change together. So if you have a bunch of items that change often, you can kind of group or aggregate those things into a specific module to isolate them away from the things that rarely change. So this kind of helps with preventing tight coupling between volatile and stable code. So for instance, you might have UI components, which change pretty often in most projects, all aggregated together in one module or package. Your domain models, which rarely change, could be into their own package or module. Migrations, which are very stable, could also sit in a specific folder so that they're isolated from each other, and you concentrate more effort onto areas where volatility is high. Why does this work in general? It sort of reduces the blast radius of changes. Grouping by plugin versus core. So again, this is similar to stability. The idea is that you organize code on how the system is exposed to the outside world. So whether that's an API, a CLI, or some sort of eventing system, you may have a module that is an HTTP API, a GraphQL API module, a CLI interfaces module, an event consumers or an event producers module. The idea is it centralizes interface points and sort of forces clean contracts so that your HTTP API code isn't intermixed with your GraphQL code or your event code. These are only some of the more common grouping types and practices out there. There's an immense number of different ways that you can group or organize code. Some of the others that are worth thinking about or looking at are by cognitive context, which is sort of how you visualize the system in your brain and imparting that structure onto the code base itself. By data ownership concepts or data authority concepts, you split code by who owns or controls the data that specific code deals with. By temporal scope, the duration of the life cycle of logic, for instance, runtime, init, and teardown. You could group by deployment granularity, so folder structures which are based around the sort of independently deployed pieces of your application. You may have multiple background worker services, so you organize your code around each of those, and then you have a main web application, so you have that organization construct. You can also organize by security domain, which breaks up code into areas based on some concept of authorization boundaries or boundaries of trust to help you track which pieces need more sort of explicit validation and access controls. You can organize by workflows or state machines. So if you're thinking about your system in the perspective of flow of how logic groupings or around system transitions happen, like payment flows or order processing, you can organize into chunks based on those state machines or those transitions. You can organize by testability. If you're a test hound, you can organize code by the ease of which it can be tested. And you can also organize by risk or impact, where you sort of group code by how high or devastating the impact of a failure could be system-wide if that specific component failed. There's loads of different ways for you to group and organize and structure and build these things up in a sort of file and tree structure. The idea isn't necessarily to pick one and stick to it. It's to realize that there are sort of all of these taxonomies and ways of categorizing code and finding across all these different types of groupings which ones work for the specific system or code design that you are building up. As your code base grows, you're going to run into a very specific situation. You'll write some new code and it won't seem to fit anywhere obvious. And that's normal. No structure is perfect, and your requirements are always going to change and differ over time. But here's a trap that you should really try to avoid. Resist the urge to just shortcut and dump code into some vaguely named module or into a random place, just because it feels uncomfortable. When you hit that moment, stop and think about the piece of code that you're holding. Why doesn't it fit? Is it doing too many things? Is it escaping the boundaries of the module it's in? Is it too specific? Is it too generic? Sometimes the issue isn't really with the code itself, it's how your project is currently grouped. It could be that your current areas of concern are just too loosely defined, and it might be down to needing to do some splitting between different modules and breaking things up even more. When that happens, it's often a sign that your module boundaries, they sort of need to change. Some areas maybe need to lose ground, or some areas maybe need to gain ground. And if what you're adding is really actually something new, that is truly new to your code base, that there isn't an existing place for it to live, then make sure that you give it a clear, well-articulated place to live that outlines that thing's responsibility. If you're not sure where it belongs yet, one trick I like is to prefix it with something like WIP underscore that forces a little discomfort and keeps it visible that this thing isn't fitting properly, so that as the structure evolves further down the road, it will naturally kind of get moved into the right place, because you'll feel really awkward about having a module named WIP in your repository for too long of a time. Now, if your code is really new and is just trying to do too many things, that's another sure sign that it's time to do some structural changes. Find ways to split that code up and move the pieces into the areas where they actually belong. So for instance, if you have a class which is doing reads on your database and then mutations on your database, but it's doing against two completely different types or resources that you're storing and manage, and normally you've got a module for this component and you've got a module for this component, and for some reason you've decided to amalgamate operations on these two disparate things in this class, it's time to break that up and restructure so that things live in the appropriate places. You'll often find, once you think about it that way, that there are existing homes already for many of the pieces that are in this awkward thing, or new homes that are actually much clearer once you kind of step back. Now, one more important point, it's okay if your structures feel a bit messy for a while. Your organization is always basically going to lag behind your newest ideas and implementations, because it's hard to see the big picture when you're way down in the weeds. You're not going to have an answer right away for every single line of code that you write before you write that line of code. Sometimes it'll be easy because it's just a query against a specific resource and you have a module for that and there's a specific file in there that deals with this resource type. Sometimes it won't. Sometimes you have to kind of let your brain dump things out before you can actually organize it in a meaningful way. And finally, here's a good gut check. If something feels really hard to test, it's probably too complex and trying to take on too many responsibilities. It's a good sure sign that something has just got too much going on inside of it if you can't really carve out concrete tests against it. Don't shortcut. Don't panic when something doesn't fit. Use these moments as opportunities to evolve your project structure and make it stronger over time. Don't center your entire project around a single overloaded concept. Like, for instance, a models folder, and then sort of shoveling unrelated code into it. If you do this, where everything starts revolving around one catch-all folder, it's absolutely going to turn into basically a junk folder. And down the road, it's going to be really hard to disentangle all of that. In fact, at a point, it's no better than just having everything at the root of your repo. When this happens, the responsibilities of different parts of your code base get muddy and confusing. So if you're starting to add modules, packages, or folders, stop and ask, does this code really belong here? What's the clear reason this code should be grouped together? Terms like models are super overloaded. They can mean 100 different things depending on the context or depending on the framework that you're using, if you're using a framework. Instead, when you're first creating new organizational units, focus on breaking up things based on responsibility, features, logical boundaries, not based purely on the type of code like models or helpers. As your code grows, you'll naturally start seeing more and more distinct concepts emerge, things like layers, features, and responsibilities. And you should ride that wave, let your structure evolve in a flexible way, because flexible structures scale better and they reduce long-term confusion in your code base. Basically, don't make everything revolve around something specific in your code base where you load those things up and start to dump things in there that aren't necessarily related to that core concept. Let's talk about interfaces for a second. And just to be clear, when I say interfaces, I don't mean your UI, and I'm not really talking about a database interface either. When we're talking about code structures and organization, interfaces are about the point of intersection between different parts of your code. In other words, an interface defines how you interact with a logical unit, not how that unit works internally. This is a super powerful concept because it gives you a way to add mid-level organization and to buffer different areas of your code base from change elsewhere. Here's an example. Let's say you have a module that handles sort of network sockets. That module might have a bunch of internal functions, types, classes, structs, traits, whatever your language uses, all dealing with things like opening sockets, managing connections, communicating over sockets, cleaning up TCP sockets when things shut down. But here's the thing, the rest of your code base doesn't care about any of that. All it wants is a socket it can send messages through. To make your project easier to maintain, you'd want to keep most of that module private and expose just a small, well-designed interface. That interface could be a couple of functions, a class, a struct, whatever makes sense, but it should abstract away all the lower level and lowest level complexity away from the rest of your code base. If all your code has to directly wrangle the low-level socket logic, anytime you change that logic, you risk introducing breakages everywhere else in your code base. But with a good interface, you insulate the rest of your code and buy yourself some flexibility. For example, you could swap out the underlying library or change how you negotiate connections, all without worrying about the other parts of the code that are simply just wanting to use and create and drop sockets. The key principle really here is that when it comes to your modules and packages and all these different pieces, only really expose what's necessary. Good interfaces make your code more modular, more flexible, and way easier to maintain as it grows. What we just talked about, interfaces, actually feeds into a sort of bigger topic, which is around cohesion, specifically module cohesion. What do I mean by cohesion? There's generally two overarching types of cohesion that we're going to deal with. One is high cohesion and one is low cohesion. High cohesion code is sort of closely related or tightly integrated or connected. Low cohesion code is code that's mixed together that doesn't really have a very clear common purpose. Inside of a module or any kind of organizational unit, whether it's a module or a package or a folder, you generally want high cohesion. So those things that live in there should have some commonality in what they deal with and what they do, or their responsibility. The code in that module should be clearly related or tightly integrated. For example, if you have an authentication module, it should really only deal with authenticating users. It shouldn't have code for authorization or view templates or routing for your application that would mixing concepts up in this same module. Now here's a simple gut check. If you can't clearly describe what a module does in a sentence, it's probably suffering from low cohesion. For example, if I can say about a specific module that it deals with authenticating a user and ensuring that they are who they are, cool. If I say this module deals with authenticating a user, resetting their password, managing their profile, and showing the login and logout views and handling the routes for those things, that's pretty overloaded module. It's got a lot of things going on in it, and not all of them are that coupled together. So in general, you want high cohesion within a module, and you want low cohesion between individual modules themselves. Now let's talk a little bit about how dependencies should flow between your modules. We'll go through some principles. It's the place where you're probably going to be chronically unhappy with how tightly cohesive specific parts of your modules are. So number one, lower level modules shouldn't really rely on higher level modules. And what I mean by that is you want your dependencies to generally flow in one direction, and that direction should be downward. You shouldn't have a sub-module of another module depending on things that are higher above it. If you want that nice isolation and separation of concern, you should make a habit of ensuring that you're only ever passing things in and not really reaching out of a lower level module up and over to another module somewhere else. This makes your architecture much easier to reason about and avoids creating sort of tangled circular dependency problems. When you pass data between modules, do it through the aforementioned interfaces and use concrete types. Don't pass data using direct references to other modules, and absolutely avoid using global variables to share state in between these different areas. If you have state, it should live somewhere central in your application, and you should allow your modules to affect it, but only through a downward controlled mechanism. Think of the interactions between modules as sort of a contract. Both sides need to agree upfront what they're going to provide and what their expectations are for each other. And if either side strays from that agreement, you're going to catch it right away. Going back to the concept of shared state, don't let multiple modules manipulate the same data or shared state or global sort of top level data. This is a really common source of bugs, and it makes it almost impossible to reason about how a system behaves when all of these sort of disparate elements everywhere peppered all throughout your application or your system are all editing and making changes. What you can end up with is weird sort of race conditions and things like that, where something doesn't update in time from one side and the other side misses it, or other kind of weird problems like that are hard to trace and understand. If you need to bridge between modules, use patterns like adapters or facades. These act as a sort of barrier between the internals of individual modules and give you much more flexibility to evolve those modules independently. And if you do find areas of your code starting to get tangled, don't panic. First, sort of document the interdependence clearly. Then start thinking about the long term, like how can you gradually, through small incremental changes, start to untangle things. And we'll talk a little bit further on about how to rescue a messy code base, but it's worth mentioning up front that it's something that you need to kind of keep an eye out for. Finally, one of the best ways to manage dependencies cleanly is to use dependency injection or inversion of control. And we'll talk about that shortly as well. The general idea with IOC, though, just to give you some heads up, is it's to pass data or behavior into modules through sort of function arguments, trait objects, or whatever patterns make sense for your structured code. And that kind of keeps your modules decoupled and makes your code base far more flexible and sort of testable. I'm willing to bet that you're using a lot of generic types. These are things like strings, ints, floats. Maybe you're using different types of floats, for instance, float 32s, float 64s. You're using the sort of innate, inbuilt types from your language. You know what I'm talking about. You've probably got variables like thing ID that's just a plain old string. If you want to save yourself some grief later on, here's a sort of simple practice that pays off pretty big in the long run. Make those things concrete. It only takes a little extra effort, and the benefits really start to add up as your code base grows. For example, instead of just using a string for your user ID, you could implement a user ID type. Under the hood, it's still just a string, but across your code base, it gives much more clarity and context to what that thing is. User ID equals some ID versus created user ID equals user ID. It's just easier to read and immediately signals what kind of data you're dealing with. The good news, many languages support this natively. Rust, for instance, has first-class support for these types of concepts. Python, you can use the new type from the typing module in order to define these things around an innate internal type. Using concrete types makes your code more readable and adds important context to the places where those variables live. And for values that have a finite domain, say the status on an order record, don't just use a string. Use an enum. That way it's clearer in your code base what the possible values are for that status. The same principle applies when you're passing messages, sort of things that you would pass through JSON payloads, RPC calls, between threads even, or between different areas of your code. Creating a concrete type to represent the message will make the behavior of your application more documented, and the data flow of things moving around in your application much more understandable. And as an added bonus, materializing these types can help you reduce or even avoid a whole class of different types of bugs. Next time you're about to reach for a plain old string or integer, take a second and ask, would a concrete type make this clearer and cleaner? And in most cases, it probably will. When you're in a hurry, it's tempting to name things with single characters or abbreviations, sometimes really obscure abbreviations, or maybe you think no one else will ever have to touch this method or read this code. It's going to sit here forever and nobody's ever going to be worried about it or touch it. Or this method only gets called in one place, no big deal if its name is vague. You should aim to be verbose with naming things all the time, no matter the situation. Name them for the behavior that they represent. Modern type hinting and signatures definitely help, but clear descriptive names make it way easier to quickly understand what something does. Consistent casing also matters. You don't have to stick to one casing style consistently across your whole code base, but you should use consistent casing styles in the areas that you've opted to use them for consistently. For example, if your constants are always uppercase, don't use uppercase naming for method names. If your classes are camel case and your functions are snake case, stick to that convention. Don't mix or intermingle them. Consistent casing helps you instantly know what something is when you're working in the code base. But when you break those conventions, things can get confusing really, really fast. Along those same lines, avoid abbreviations unless they're really, really common. Even if your organization uses tons of internal acronyms, those can change over time. And new hires, they'll struggle to understand what the code is actually doing based on these abbreviations that may no longer even exist inside of your organization. Another thing to do is use consistent prefixing. Don't fall back on generic names like controller or service that tells you nothing about what's inside of something. Controller, model, service, these are all really overloaded terms in software engineering, and you should try to avoid them as much as you possibly can, and try and target describing the behavior of a thing as succinctly and concisely as you possibly can when naming it. Now here's one last tip. If you're finding yourself writing a really vague name, that might be a sign that the thing itself needs rethinking. For example, if you're struggling to name a class or struct based on what it holds or what it does, maybe it's doing too many things and it needs to be broken up. So bottom line, naming is hard, but it's worth taking the time to do it well, because clear, consistent, and descriptive names will save you and everyone else a ton of frustration as your project grows. Let's talk about how to think about the flow of your code, especially when you're writing your individual code files. Here's the idea. Code is a flow. It's not a trip through a maze. And when I say flow, I don't mean like vibe coding with an LLM. I mean that there is a natural cadence to how code progresses. In most modern languages, the days of having to declare everything in a specific order, like methods before they're used, are long gone. We have things like scope hoisting and all these other things, but in general, the way that most languages are compiled now, you can have things ordered generally in a more reasonable way to aid in reading. So you should take advantage of that and organize your code files so they kind of read top down, like a story or a narrative. Start with your public interfaces, things other parts of your code base will call to interact with this file or module. And then as you move down the file, work your way into the implementation details. Internal private pieces should naturally come further down so that anyone reading the file can understand the higher level behavior first, and then drill into the details as they need to. Declare statics or constants right at the top, and use section headings in comments form to create sort of clear visual boundaries through the code when these areas change. This makes it way easier for someone reading the file to sort of jump to specific areas and understand the structure at a glance. Above all, don't make people, including yourself, jump around the file just to figure out what's going on. When a file's organized top down, document with clear sections, it reads more naturally for somebody. And that's how it should feel, like a flow or like a story that they're reading that's building up to individual details and character development, not a maze that they have to navigate through in order to find the golden nugget at the center. Next time you're writing a file, think about the story you're telling, lead with the public behavior, and let the details flow sort of naturally below that. Let's be clear, writing tests can be a slog. You probably avoid it at the outset. We all do. It feels like it slows your progress early on in a project. Tests are integral to good structuring and organization. There are lots of types of tests: property-based tests, end-to-end tests, unit tests. The list goes on, and there are lots of subclasses of types of tests in that hierarchy. But in terms of your code organization, think of your tests as an insurance policy. They give you the freedom to move, change, and reorganize your code with way more confidence than you would normally without them. As long as your test passed, you can trust that your changes are actually good. And when you're refactoring around structure, having a solid test suite is like having a chess grandmaster sitting next to you who is checking every move before you make it. The more tests you have covering your critical logic and functionality, the more confidence you'll have about changes, and the less fear you'll have about moving things around to get to a better structure. And here's the thing: if you don't write tests, the fact is your bugs will, but it won't be the kind of tests that you want. So invest in tests earlier, because they give you the freedom to refactor and the safety net to build a clean, evolving code base. Let's talk about one of the most important habits for keeping your code base healthy. Main way to do that is to refactor often. Once you're past sort of the initial phase and you're starting to settle into the long haul on a project, you should make a point to refactor when opportunities arise. As you keep working, you'll start to see a clearer picture of the major functional areas in your project. Logical groupings and similarities between areas of your code base will start to sort of emerge organically, and you'll naturally want to start pulling them together into more meaningful organizational unit. But here's the thing: you shouldn't wait necessarily for the perfect moment to do a big cleanup. You should be making small, regular improvements as you go, and not leaving it until the code is like a complete mess and smacking you in the face that it needs some attention. Here are some small things that you can do to kind of stave off that point where you really have to commit to an overarching refactor of things. Number one is to rename variables and functions so their behavior is more clear whenever you come across them. Number two is to isolate and extract repetitive code into functions. Number three, restructure or split files that are becoming too sprawling. When you're starting to feel like a file is really big and it's got too many areas of responsibility, you should be taking chunks out of that and dumping them into tertiary files or other packages where they make more sense. And remove dead code, or simply just over-engineered code that was built for a use case that never happened. Refactoring should be something that you generally do constantly at different scales. It's not a big one-off task that you save for later. Small incremental improvements over time will lead to bigger wins in the long run. And don't turn a blind eye to parts of the code that you know could be organized better. If it feels wrong, it probably needs attention. And if you're working in an organization, it can be really hard to justify a really big refactor. Commercial teams will often just say no, but there's a way around that, really. It's easier for you to sort of pad out your development tasks a little bit and bake in refactoring and structuring work alongside feature development, so it's a normal part of your everyday development and engineering. At the end of the day, refactoring is more of a habit than some sort of software engineering task that happens in the life cycle of a project. It's not a dirty word. The more you practice refactoring regularly, the stronger, cleaner, and more maintainable your code base is going to end up being. Another mindset shift that will serve you really well in the long term is to think about coding for future refactoring. Look, requirements change over time. Projects grow, needs evolve, sometimes the money runs out, sometimes more money comes in. But one thing sort of stays constant: clean, simple code will always win over overly complex, tangled spaghetti. And future you will definitely thank you for adopting some good habits now. First, keep your functions and methods reasonably short. Limit what they do. One-liner functions are probably too small, but big sprawling if, else, and looping monsters are not great either. And here's a simple trick. If you struggle to name the function based on what it does, that's probably a sign that you need to break it apart. What I mean by that is, if you can't write a concise single line of text that tells the reader exactly what's happening in that function, then that function is doing too many things and needs to be broken apart. Second, use clear descriptive names. A good name goes a long way, and it will probably help you when you're refactoring code later on and you're trying to trace the path of a specific variable or where specific function calls happen. Third, limit interdependence. Use interfaces and other patterns so your function calls don't end up looking like a giant spider web across your application. Reducing spread of dependence makes it way easier to move things around when the time comes. Fourth, be more functional. Try to write pure functions as often as possible, functions with limited or no side effects. These are way easier to test and way easier to refactor. Fifth, limit cyclomatic complexity. This is a measure of how many independent paths exist through your code, basically how many forks in the road happen when your code is executed. Lower is better. If your cyclomatic complexity is high, it's a good sign that your code is starting to get spaghetti-like. Make it a habit to break up big, complex functions into smaller chunks over time, and use tools like Radon and Python to test complexity in your pre-commit hooks. Building these habits now will make your code way easier to refactor later and will help your project stay flexible and maintainable as it evolves. Here's another simple but powerful sort of mindset shift, and that's design code to be deleted, which might seem kind of weird in the fact that you are building your code with the idea that later down the road you're going to get rid of it. But when you're structuring your code, you want to structure it in a way that makes removal of it clean and easy. This actually reverses a lot of common design heuristics. Most of us naturally think about adding functionality and not removing it, but code that's easy to delete tends to also be well isolated, loosely coupled, and clearly scoped. And that matters because over time, requirements change, features get deprecated, business needs shift. And if removing a piece of code turns into a nightmare, that's a sign that your structure is just far too tangled. So how do you design code specifically for deletion? Well, you structure code into clear, isolated units. You minimize cross-module dependencies. You keep interfaces tight and explicit, and you avoid leaking internal details across layers. These are all things that we've already talked about in this video, so you can go back and see some of the more detailed information about those areas, but they're generally things that you need to apply in the back of your head as you're writing code, but in the context of making something that can be easily deleted later on. When you do this, removing a feature or component should almost feel like surgical. You should be able to delete a module and know that you're not going to accidentally break something 10 layers deep somewhere else. So next time that you're designing a part of your project, don't just ask, how do I add this thing? Ask, how easy would it be for me to remove this later if I needed to? Designing for deletion and your future self will basically thank you for putting in the effort. Now, I've purposefully avoided talking about design patterns explicitly up to this point because I want to talk about how to think about them in the context of structuring your code. Patterns are sort of the lingua franca of programming languages. Sometimes they're about performance, but more often they're really about providing a shared language for communicating the complexity of certain logic, and mostly to other developers. You should think critically about when a pattern actually becomes necessary in your project. Adopting patterns too early can cause more problems than it actually solves. Don't adopt a specific pattern just because you think you might need it months down the road. Projects evolve, and it's usually better to wait until it's clear that there's a real need for a pattern. Forcing a pattern too early can make your code unnecessarily complex, less readable, and harder to maintain. And the worst part, half-implemented patterns can be even more confusing than if you just not used the pattern at all. So you need to shift a little bit and think of patterns as tools, not as end goals for beautiful code patterns or beautiful code design or anything like that. Having your entire project perfectly organized into patterns by the end isn't realistic, and it's not the goal of software engineering. If you find yourself adding a lot of boilerplate all over the place, you're probably and potentially thinking a lot or too much about patterns. When does it make sense to actually introduce a pattern into a code base? Generally, there's a few reasons why you would reach for a specific pattern. Things like you noticed repetition in your code or your structure. Some of the complexity in your code base is growing and it's getting harder to extend or maintain, or you can see clear pain points that you know in your mind that a specific pattern would solve that problem. And let's be clear, there are some domains where certain patterns will almost always apply. And in those cases, it's fine to opt into using them early on in the project. But for most code, you don't need complex patterns and implementations up front. Patterns should generally grow organically and on an as-needed basis. And you should be okay with refactoring away from a pattern later if it turns out that it wasn't the right fit for the problem that you were trying to solve. So think of patterns as tools in your toolbox, not something that you have to force into every project. Use them when they solve a real problem, not just to tick a box that you've used the strategy pattern or the observer pattern or factory methods and things like that. Now next, let's talk a little bit about inversion of control. This one's a little trickier to explain, but once you get it, you'll start using it generally everywhere. Your knee-jerk reaction might be to have your classes or functions build their own dependencies. But instead, think of this like dependency injection, but happening inside your code base, not just through an external library. Here's a simple example in Python. In this case, the service doesn't construct its own dependencies, it simply receives them. You can pass dependencies through setter ejections, constructor arguments, factory or provider registration, but why would you do this? Well, it makes it easier to test components in isolation. It lets you swap behaviors more easily with minimal side effects, and it scales well because you're using partials and dependency registration patterns. You can think of this as principle as sort of locality over globality. You want to pass in context and config to the places that need it rather than having everything reach into the global state to pull down what they need. Smaller, more focused scopes help you reason about the immediate problem at hand instead of figuring out how to get the things that you need from elsewhere in the code base. It's kind of like baking a cake. You get all the ingredients out of the cupboard and mix them together. Your cake tin doesn't reach into the cupboard and grab the flour itself. Same principle. You'll end up with a code base that's cleaner, more modular, and far easier to evolve over time. Now let's touch on an advanced but super important concept. I'm not sure what the exact name is for this thing. It's usually, or this concept, it's usually, the thing I always refer to it as the anti-corruption layer. But it's essentially a interface between bounded contexts. So when you have different parts of your system, or when your system talks to external systems, you want a clear layer that sort of acts as a translator between them. It's often hidden in software diagrams and things like that. It's not something that pops out as an individual component. It's generally put in there by somebody with sufficient level of experience that they formed a habit of forming these translation layers. It's a crucial part of keeping your system clean and massively decoupled. Without it, you risk leaking concepts and models from one part of your system into another, and that can lead to tight coupling and really messy boundaries between different systems. With a good anti-corruption layer, each part of your system can stay focused on its own domain and interact with other systems in a controlled, more predictable way. If you're designing systems with multiple domains or integrating with external services, make sure to add a proper anti-corruption layer. It's one of those invisible pieces of systems that really pays off in the long run. Right. So you've stuck your foot in it. You went too far. You're a hair's breadth away from throwing the entire code base out and starting over completely from scratch. Before you do that, here's some advice that might just save your code base from the bin. First, identify where the pain points really are. What is it that makes you dread working in this code? Where do you get the most frustrated? What are the things that trigger this sort of visceral chuck it in the trash can attitude? Grab a notebook or a whiteboard and sketch some quick rough diagrams of how things currently work. Get your mental model straight about what you've actually created so far. Start looking for obvious problems. Are there God objects? Is there spaghetti dependencies, circular references, tightly coupled modules that are trying to do too much all at once? Really identify what those things are. Next, add some tests around some of the most critical and fragile parts of your code. These will give you a safety net as you start to kind of make changes to the wider code base to ensure that things are still operating the way that you expect them to. And then from that point onward, you should target small incremental change, not big sweeping refactors. Look for little things that you can improve as you go and gradually shift your code base out of the corner that it's been backed into. Rename variables to be clear, extract large chunks of code into smaller functions, update outdated comments, flatten complicated or ill-fitting patterns, create boundaries around chaotic areas, move them into separate modules and define clear interfaces for how other parts of the system interact with them. Basically cordon off the scary bits and give yourself some breathing room to deal with them in smaller pieces. Importantly, remove dead code. If it's commented out and you're using source control, you can always get it back if you need it. There's no reason to let it clutter up the project. And then you should prioritize refactoring and cleanup by the value that some component piece gives or represents in your project. Focus on the parts of your application that are the most important first. Don't waste time cleaning things up that don't really matter that much. Think of this process as sort of like knitting a sweater, right? If you make a mistake halfway through, you don't throw out the whole sweater. You carefully unpick the problem areas and rework them until you're back to a place where you feel good about moving forward again. Let's talk about knowing when to stop polishing. Perfect code can in fact actually become a bit of a liability. The best engineers know when to stop polishing code. And that's kind of typified by the idea that robust is enough, especially under pressure. If you refine an abstraction or system too far past a sort of axial point, it starts to become brittle. And the more polished it gets, the more fragile it can become to sort of real world use and change. You have to accept that your code does not need to be perfect. It needs to be correct, and it needs to be dependable. That means it should handle errors and surprises gracefully. It should keep running when things go sideways. You're not chasing the most elegant possible structures and algorithms. You're chasing a working, solid solution that will hold up months or years down the line. Have you ever felt like you have been solving the same bug again and again and again? Here's the thing, you might not be solving the real problem. You're just popping sort of the digital equivalent of a Tylenol. So let's fix that. Stick with me. Imagine that you keep getting these terrible headaches. So you take a Tylenol, headache goes away, but a day later, boom, it's back. More Tylenol, rinse, repeat. You're treating the symptom and not the cause. Maybe it's dehydration or stress, or heck, maybe it's just poor posture from sitting in your chair really awkwardly bent over writing code, but you're not going any deeper. You're stuck in this weird loop of just dealing with the symptoms of a deeper problem. Now take that same idea and bring it into your code base. You see a bug in one module, you patch it, all your tests are green until another bug pops up in some other unrelated area or loosely related area, and another and another. The bugs, they're just indicators, symptoms. There's something deeper wrong. Maybe it's a bad abstraction. Maybe it's inconsistent boundaries between modules. Maybe your implementation just wasn't built to scale specifically in the way that you're using it. The kicker is that when you keep fixing bugs without addressing the root cause, you can actually introduce more bugs because you're patching holes in essentially what is a sinking ship. How do you get to the real problem? One way that I love to do this is by asking what's called the 3 whys. So you can do this on your own, or even better, have another engineer sort of play devil's advocate with you. But the idea is that you progressively ask yourself up to 3 times the same question and try to answer it. So you would go, why was the order invalid? Because it had an ID that didn't match the standard. Why? Because IDs are just generic strings everywhere. But why? Because we never implemented a proper order ID type with validation properties. There's your root cause. Not bad order data, not a one-off user error. It's a missing domain or concept in your system, which if you had implemented it earlier, would have mitigated this problem. So here's the truth. Systems rot when we fix bugs without understanding them. Every bug is a thread, and if you pull it, it can lead you to the real weave of your system's design flaws. So next time you're tempted to slap up a quick fix, stop, pull on the thread, ask the 3 whys, and solve the right problem, not just the obvious one. Right, it's a couple of weeks since I initially recorded this video, and I've been kind of stuck in editing and learning how to edit, learning how to do audio engineering stuff, learning how to cut videos, how to make little animations and things like that, and do title cards. It's been a pretty big learning curve. This is the first video that I've really done, other than sort of Minecraft videos for my son. Just to say, I hope that you enjoyed it. The original outro that I had sort of recorded for this video was frankly terrible, and I was tired after recording for far too long. If you really liked the video, please subscribe, like, leave a comment, ask for other ideas or things that you want me to do deep dives on. I've got a couple more videos that are on the way, including a deep dive on some specific types of patterns for software engineering. Look forward to kind of getting those done, and yeah, thank you for watching.